Hello everyone and welcome to Wiki Comparing QGIS Service Workshop number 3 dedicated to urban studies. My name is Daria, I'm from Novelties, and today we are here to learn how to use Wikio platform products in QGIS software. And our topic for today is going to be monitoring air pollution and land surface temperature in urban areas of Italy. So first let's see what are these urban studies. So urban studies are an interdisciplinary field that examines various aspects of urban environments, including their development, dynamics, and impacts on society. This field seeks to understand the complex interactions within urban spaces and the challenges and opportunities they present. So today, in this training, we will explore two critical aspects of urban studies, such as air quality and urban heat islands. Air pollution monitoring helps urban planners and policymakers develop strategies to improve air quality through measures like emission controls, transportation planning, and industrial regulation. Urban heat islands, in their turn, refer to localized areas in urban environments where temperatures are higher than their surrounding rural areas. This phenomenon is primarily attributed to human activities such as the construction of buildings and roads, which alter the natural characteristics of the land surfaces. So studying such aspect as urban heat islands allows us to mitigate their effects, such as intercooperation of green spaces or the use of cool roofing materials. So this is shortly um, introduction to our topic. And as I said, today we're going to use a QGIS software, which is a geographical information system. And the data we're going to use in it is our products from Wikio platform. And I will briefly show you those products. So first of all, we're going to use two products from Vecchio platform, and we're gonna have a help, let's say, from some external data. So first product from Vecchio platform is the CAMS European Air Quality Forecast. So this data set, as you can see, provides daily air quality analysis and forecast for Europe. Um, Here specifically, we're gonna use, I think, nitrogen dioxide concentration. Yes. And for the second product we're gonna use is a Urban Atlas product, which is yes, land cover and land use data for functional urban areas. So specifically in urban areas. And additionally, we're gonna use a database. Let me see. Yes, database that's been downloaded from this website. It's a database of Italian cities. It has basically all the cities in Italy with information about its latitude, longitude, the population, and so on. We're going to implement it. And also to see the temperature, the land surface temperature. As I said, we're going to study uh, this characteristic. We will use satellite image from Landsat 8. And to have this image, we're gonna go to Earth Explorer portal, which is let me yes, this is this website. So this is USGS. This is another platform in which you can have Landsat 8 images from which you can download it. I'm not going to explain how to download products from Landsat or from Wikio platform. Both of them are, they have tutorials on how to do it, like separate tutorials. Like for example, here we have a little tutorial on how to download it. This link and a link also on how to download data from Wikio platform will be included in a document because yeah, I did mention that, but this video is not the only video, not the only material uh, to um, to use. You can use to replicate all the step-by-step procedure of this tutorial. There is also a document, Word document or PDF document with all the procedure written and also with all the links provided there and additional information which I'm not gonna discuss today, like tutorials on how to download data. So yes, And all the data, of course, that you're going to use going to be already presented, already given to you in one folder with the project in QGIS itself and with this video and tutorial in like document. But also what I want to talk before we move to QGIS project is um, this link which you're gonna use, which you kind of need to use to download a QGIS plugin, which is called NetCDF to QGIS plugin. And this plugin has been developed here in Novelties in order to facilitate users' experience of importing NetCDF files into QGIS. Because QGIS initially naturally has its own tools into how to import NetCDF files, but they are might be a bit too overwhelming and too complicated for beginners, for like users who never like saw never seen QGIS before, but also for experienced QGIS users, it can be sometimes overwhelming. So this QGIS plugin is quite simple, quite straightforward, and it allows us to have faster and better implementation of NetCDF files. So that was it for a little introduction. I hope I didn't forget anything. If something, I'm gonna go back to it. So now we are going to QGIS project and we'll create new QGIS project. That is how it's gonna look like. And you're supposed to see something like this and having processing toolbox here or may not have. If you don't, you just click on this little gear here. So first we have just a blank project without anything, and first we want to do is to add a background layer. So we have a map of the whole world to better better navigate through our data. So to do so, we go first to Layer tab here. We go to Add Layer and we choose Add XYZ Layer option. Here, usually if you just first time it's your first time with QGIS, you probably won't have anything here, like you won't have all this list. I already have. So this is all the layers you can add, like it's gonna be here. If you add your own one, two, whatever. We're gonna add Google Satellite Hybrid one. I would add, and you see that we have a map, which like that's basically Google Maps. Like that's how you see it when you go to Google Maps and you turn on a satellite image layer on. So the more you zoom in, the more details you see. You see more cities, roads, well, and like geographical features too. So to do so, to have this layer when you don't have anything here yet, you put new. Here you put a name, whatever you want, and a URL. I'm not going to give URL. It's already in a document. It's quite not evident URL. But also it means that you can use any other layer, like background layer, what you want. It could be open maps. It can be other ways of like other types of Google Maps or like whatever you want. So after you added name and URL, you click on OK, and when it appears here, you put load if it wasn't load, and then add. So like this, we have our background layer. And as I already said, we're going to study specifically Italy. So we will zoom a bit and you see how our map is adjusting when we zoom in. You see how many more details we have and zoom out, like in Google Maps. So that's all our preparation, and let's move to the first exercise. So in our first exercise, we will focus on air quality, and for this we will look at the nitrogen dioxide concentration. This variable, nitrogen dioxide, we have it from this CAMS forecast product for Europe from Wikio platform. And this is exactly a netcdf file format. So we will use our plugin I told you about before to insert this data into QGIS. So I'll click on this little icon, and that's how our plugin looks like. So here we have window for files we add, and here for variables. So to add file, you can click on little plus and then navigate to the folder with your data and then add open, click open, sorry. Or you can do as I will do, I'll navigate to my folder with my data, and I need this exact data file, air quality cams 06 2021 conv. So this file, I'm just dragging and dropping it, and that's it. So here, this is, as you see, this file has several variables. You can see there is our nitrogen dioxide concentration we need. There is also, I think, carbon dioxide, oxygen, yeah, you see like nitrogen monoxide and many others, but we are only interested in this first variable. Also, this file has been pre-treated, so it's not exactly this, like the clean, like pure data downloaded from Wikio platform. It's been pre-treated before, so you can either use it, or maybe if you want to learn yourself how to adjust the data. Sometimes data, well, pure data is not exactly what you want to use in your studies, so you can adjust it yourself for this workshop. So what we're going to do, we choose our variable, is the first one, NO2 concentration. We right click and onto three options, we choose first one, add layers. So here we see all the dates, so all the like well, all the frames, time frames we have. And if you look down, you see that there's a lot of data, like there's 720 time frames, which is a lot. We're not gonna edit them all, of course, because it's a lot of work, and also I think QGIS actually might crash from amount of information. So what we're gonna do, we're gonna focus only on the first day of June. So yeah, it's yes, first day of June here, and you see that every day, each day there's 24 time frames. So from well midnight to again to midnight. So we will choose all these 24 time frames for the first day. So we choose this and we go till the last one, and we hold in shift and we click to the last one. We all have been chosen, selected. You also can select them one by holding control, but well, that's enough. And then we put like we check add and close, and they are all added to our project. You can see they're all grouped in one, and you can untick a box to see like the evolution of our air quality. But again, they have only hourly data, and what we want to do is um, having one value for this day. So we want a mean value for this day. And to do so, we can use a function which is called cell statistics in QGIS. So now we're going to refer to our processing toolbox. Processing toolbox is very useful panel here in QGIS. Me personally, I like it being open because you can access all the functions you want. You can make it smaller. Here in the process toolbox, if you don't have it, as I said again, you can just click on this little gear and it will appear. So we need cell statistics. To not go through all the functions, we just put cell and we see cell statistics. I already used it, so it shows me. Cell statistics, double click, and we have this window. So what we're gonna do, we're gonna go to input layers, and we see all the layers we have. I'll choose select all, but untick Google Satellite Hybrid because, well, it's our background, we don't need it. When I click on OK, it shows that we have 24 inputs selected. Great. We choose any of the layers as a reference layer. And then you can save it to temporary file if you want or not. Here in this during tutorial, I'm not gonna save anything, but in a workshop, like in a written tutorial, like a document of it, we usually save it, so you have more like references, but I'm not gonna do it here because it takes a bit more time. It's up to you to save you to temporary files or not, save to permanent files, sorry, because, well, if you don't save it to some file like on your computer, I don't know. Then next time and you close QGIS, and next time you open it, it won't have these layers edit. Like it will have its name here, but it won't have it depicted because, well, you literally didn't save it, so QGIS doesn't know where to take information from. So it's up to you. If it's just one exercise and you want to move on, you might not save it. If it's or like layer you're not going to use for, it's like some, you know, just like between two steps layer. Um, but if you wanted to have this layers saved for future, of course you save them. So what I want to do, I want the statistics also to change statistic. Here you can see a drop-down menu with a lot of options, and we need mean, as I said. So we take mean. I will click on run, and it's already finished. It was so quick. So yes, we have our new layer, which is just called output layer because I didn't give it its a name. And you see this new layer, which is basically a mean layer of all our 24 raster layers we added before. But as you see, it's black and white, and our layers were different color, and it's not really representing black and white. So we're going to change its style, which is also quite useful thing to do with each layer you have to make them more representative. So we double click on our layer and then go to symbology tab. Here, first what we need to change is change render type from single band gray to single band pseudo color. And now that's our field to play. I will move a bit so you see the difference of a field of a of a layer. First, I want to change color ramp. I want to use spectral, and I want to inverse it so lower values are in blue and higher values in red. So kind of it's kind of logical for us to see when the concentration is low, it's blue, the concentration is high, it's red. So I'm clicking here, this little arrow, and I click invert color ramp. Great. Next, what I do, I'm not really interested in very precise numbers, so 2 is okay. Minimal, I will put 0, and max, I will put 25. So temperature is good. And then from continuous mode, I'm going to equal interval, and I choose 5 classes. Great. So we have 5 classes of our scale. I'll click apply. You see how it changed, and we click on OK. So here you already can see a bit, well, it's maybe not very prominent, but actually I think it's quite prominent to see this boot of Italy, and you see which part of Italy, which cities are more having high concentration of nitrogen dioxide. It's more like on the north, and of course this one is Rome, which is the capital and the biggest city. So like this, we change the style, and now we're gonna move to um, defining, estimating then this nitrogen dioxide concentration in major Italian cities. So to have it in major Italian cities, we first need to have our database of Italian cities in the first place. So for this, as I said, I told you before that we gonna use external data table, CSV table with all the cities in Italy with its population. And as we downloaded it, we're gonna add it now. So we go to layer, we're gonna go to add layer and vector layer because it's a vector layer. Have this window and we're gonna browse to it. Let me, oh, it's wrong folder. Okay, so here it is. And we have this document, CSV file, Italian cities, and we open it. So here we need to find what type is CSV. Ah, yes, sorry, I actually made a mistake. It's not a vector layer that we want to add, yes, because CSV, we need a delimited text one. Yes, sorry. My bad. Here, yes, okay, that's what we need, CSV, and we go back to load this file name, Italian cities, open. And yeah, that's what I want actually. So here we have our name, we have it's a CSV, and we need to choose our geometry, yes. So is it, yes, it's point coordinates. For X field, we choose a longitude, and that's LNG, and Y field is latitude. Great, and is it here? Yeah, okay. In this menu, record and fields options, we should tick the box first record has field names. I think it looks like this. Here it's good. Yes, yes. Okay, so after is everything is done like this, we click on add and then we close. Okay, great. So now we have many little green dots that are all spread all over the Italy. And here are more like lot of cities, as you can see, but also already we can see that here we have a big concentration of cities together, and we also see that the concentration of nitrogen dioxide is quite high, which is interesting. But we are more interested in major cities, as I said, so let's filter our cities according to population. So for this, we click on right click on our Italian cities, and we choose filter. In filter, we will set our expression as population. And population, let's say more or equal to, I don't know what's major, well, 150,000, 150,000, I think, yeah, why not? Click on OK, and up, now we have, well, drastically smaller amount of cities with this population. So we have it now. And next thing that we want to see is, okay, yeah, we see exactly our points, but what we want to actually see, so it's more like, oh, sorry, so it's more representative, is to have a concentration value, uh, yeah, concentration value at each city location. I think it's interesting and very useful. So we're gonna sample the values of this raster in each of these points. So for this, we're gonna exactly go to our toolbox, and we're gonna put sample raster values. Perfect. We're gonna choose Italian cities, yes, as our layer, and for raster layer is our output layer, and um, I don't know, well, this one not gonna change, just let's run it. Okay, and these two layers, by the way, I don't like them being here. I'm gonna drag them outside. Ah, come on. Up and up. Okay, so now we see that actually we have a new layer of points at the same locations, but now it's brown instead of green. But what's the difference is if we right click on Italian cities and go to open attribute table, we see our attribute tables with like city, latitude, longitude, and population and stuff. So initial CSV database data. And in sampled one, if we right click and go to attribute table, we see exactly the same table, but with one more layer. And in this one more layer, we see some values, very not pretty values though. And well, these values are exactly the value of nitrogen dioxide concentration in exact position, like in this latitude and longitude. But it's again some brown points, not very interesting. So let's change its properties, as we already played before, right? So we double click on it, and that's what we have. And first, we change, but it's a single symbol here, and we change it from single symbol to graduated. Yes, this one. And value is our sample one, so our concentration. The symbol, do we change symbol? Yeah, okay, first let's change color ramp. We also choose spectral. We also invert it. So it's, sorry, I forgot the word. So it's matching with our raster layer of concentration. And method, is it color, size? Yeah, color, symbol, mode. Okay, mode is here, and we need natural bricks, I think. Well, we'll see. Yes, exactly what I wanted. And that's it. Symbol. Yeah, okay. I will click on apply. And yes, yep. So now you see here that our points changed the color. So they're not brown like they were before. The symbol, so the icon also changed. They are colored exactly to the same, well, tone of the rest layer they are superposed with. But it's still, to me, it's not super pretty, so I want some advanced styling. And for that, I want to change this symbol. So I click on it, and this is a simple marker. Yes, I'm going to simple marker, sorry. And I want to change its size. I click on this little icon next to size, and I click on edit. So here in this field, so for example, before you saw it was we all had the same size, but now we can change the size of it according to some expression. So it's going to be very like tuned, not by default. An expression we want to use is this one. I copy pasted from the tutorial. So we want a square root of population divided by 100. It's just a formula to make it to according to which the size of our marker gonna change to represent the population. So it already have a preview. We click on OK, and we click on OK again. Let's apply, and yes, that's what we wanted to actually see. Let me just yeah, now you see, for example, that here the population is super big, right? We have a very big circle. Well, that's Rome, yes. Here it's smaller, that's Milan. And yeah, this is Genoa, I assume. But you also see the colors. You see that, for example, in Milan, it's quite a high concentration. In Rome, it's lower concentration. And here in Genoa, it's very, very high. So for now, well, I told you that these are the names of cities, but well, I know the names of the cities, but well, I assume it's Genoa. Let's actually display also the names to know, like, to make our analysis easier. So we still have our properties, layer properties window open. So now from symbology we go to labels, well, because we need labels, right? And we have no labels, and let's go to single labels. So now we have all these functions, and value. We need to set a value, yes, this one, to the um, name of the city. And what else we want to change? Buffer. Okay, buffer is here. In the buffer, we will draw text buffer. And yes, it will add some, it will improve our readability. Okay, we can apply. Yeah, okay, great. And click OK. So now we finally finished with our styling, with advanced styling we had. So now we have not only, well, we have the points representing the cities, the size represents its population size, and the color represents the concentration of nitrogen dioxide in the air. And now we have a little um, name label next to it to see where is it. So yeah, I was right, it was Genoa. So it looks like this. And again, looking at it, we will also see that most of like more more polluted cities of Italy with, well, polluted by the concentration of nitrogen dioxide, they all are situated in the north of Italy. We can see it, especially like the major one being Genoa and Milan stands in on the second place probably. There's also Venice. And this is quite coherent with the data we have because we know that northern Italy is quite known to have very polluted air due to its geographic location. Well, we know it has Alps, and Alps has a very high uh, mountain range. It prevents winds from circulating, from air from circulating, so air is kind of stagnating there. And also we know that the northern part of Italy is a very important industrial region of this country, well, in Europe overall. So that was it for the first exercise. It was quite simple and brief, in which we learned how to work with raster layers, yeah, from NetDF files. So now we are moving to the second part of our tutorial, to the second exercise. And in this exercise, we will learn how to work with a satellite image, which is represented as a raster file, and more like raster tile, and how to combine it with some vector data. So the image we will use here is coming from the Landsat 8 satellite, as I said before, and we use it because it has thermal bands, which are derived, no, which enable us enables us to derive surface temperatures at a high resolution. It's 100 meters. And this image is acquired between June 22nd and June 29th of 2021. So, well, according to like adherent with our time period. And the second dataset we'll use here is the Copernicus Urban Atlas, the product you can download from through the IKEA platform. And this dataset provides us land cover information for several major cities in Europe. And as we need to choose one, we will focus on Florence, which is, oh, it's not, okay, which is here. You see that concentration of nitrogen dioxide is not very high, but we will move from concentration from air pollution to urban heat islands, as I said. So the aspect showing us the land surface temperature. And we're gonna focus specifically on Florence. So yeah, this exercise serves to um, like display the urban heat island phenomenon by combining the temperature data with the land cover data. And as a result, we should see that dense urban areas tend to be hotter than the low density areas or even natural agricultural land. So, first things first, we of course need to import our data. And by importing our data, we will start with satellite images. So our satellite images are a tile of yeah, 100-meter resolution, and it's in TIFF format. And to do this, to add it, we can go to layer, and add raster layer. And we go to our folder, we go to Landsat 8. And here we have this image. Yes, that's a TIFF, great. We open it, we add it, and close. Yeah, great. Now we have our satellite image here, little part, including Florence. So you also actually can add a layer by, again, drag and drop it, like this. Well, I'm not going to do it because we already added it, but just so you know. What we're gonna do now is we need to convert this data because, well, if we really look at the values here, that's our scale, we see that it starts at 40,000 and ends at 50,000, which is kind of strange for temperature, to be honest, right? We're not really expecting these values to represent temperature. So actually, when looking at the raster metadata, We have it in a txt file. It's this one, yeah, both of them. I think, or which one? No. Yeah, MTL, yeah, visual metadata. Yeah. We will see that the raw values are only in digital numbers and they're not really representing temperature. So they have to be converted to actual temperature values. And in this text file, we also have, well, we have a lot of information. I'm not going to focus on it, but to convert it, we need to apply several expressions to our raster layer. So more specifically, we will need to multiply all the raster values, so each pixel value, because raster layer is consists of pixels, we need to multiply it by a very not pretty number, I'm not gonna even tell you this, and then add 149. And that will give us temperature in Kelvin. So without further ado, let's just, I'm gonna just show you this very, very pretty formula. For this we need a raster calculator. Uh-huh. That's a lot of things. Raster calculator, this one. And here we have expression to put. And an expression to put, we choose our layer. Let me, oh well, okay, I see what this one. Our Landsat 8 image. We need to multiply the layer by 0.0034180. Gosh, that's a big number. Okay, and then we need to add 149. Easy, right? But this will give us temperature in kelvins, and well, we are not really comfortable with kelvins, right? So we're more like used to Celsius, for example, or Fahrenheit. Well, depends on where you're from, but we will stick to Celsius. So to have it in Celsius, we will subtract 273.15. Perfect. Um, so now we have an expression and we need to tune a bit. We need to choose reference layer. This is our, well, L8 image, and output CRS is project 1. Well, output you can save or not save, and then we run. Well, it can take some time because it's a raster image, so it has a quite, well, it has quite high resolution, it's quite big, so it might take some time. I will come back to you when it's finished. So I'm back and our QGIS finished processing. We close and yeah, we see our output, which is now more representative with proper values of temperature. We already know how to change the layer style, so let's do it again. Double click, properties, symbology, single bell gray, single pseudo color. Let's choose some our color ramp, something more popping. Turbo, great. Inverted from blue to red, continuous equal interval 5, level precision 2 is enough. And let's put min 15 and max 45. We will apply it. Okay. And now we see our beautiful satellite image colored according to the temperature. And we see that actually June 2021 was quite a hot month. If you see lots of places having their land surface temperature at 45 degrees or even more, including, well, around Florence. That's a lot. That's especially here. Like, look at the color. That's quite crazy, huh? So now we have this temperature, and we're gonna move on to the next part. And in this next part, we are going to work with our another products from Vecchio platform, and it's our Copernicus Urban Atlas. So we go to layer, add layer, and vector layer, and we search for Urban Atlas. We open this strange, yeah, we search geo package, open it. You can also drag and drop it as usual. We click on add, it will propose us like which, well, this um, data actually have several layers in it, and it asks you, what do you want to add all of them or just some, one or two? We'll add all of them. We click on OK. It asks us if it's really in Europe, like the GEA reference. We say yes, we know it is. And it's already added. Yes, add and close. And oh yeah, okay. QGIS decided to take some break. Well, you already can see here on a layers tab of 3 new layers with a very long and strange name. Yes, thank you for making me deaf. Okay, so we have 3 layers, right? We can actually, let's untick all those layers and zoom to Florence because, well, we know that it's in Firenze, which is, well, Italian name. We will zoom in and let it load a bit because, well, it's a lot of data. So here we have 3 different layers. We have a, let's look at it, boundary. Let's look at it. That's only pink one, so it's a boundary of a whole urban area like metropolitan area. We have urban core, so specifically the like city, you know. And the last one we have is the okay, the last one is quite heavy. The last one we have is supposed to be our land cover data. Okay, it starts to appear. Yes, you see our, well, it's quite a heavy one because it has a lot of little polygons to load. You see it like loads in part. And this layer is actually our layer of interest. And before we move forward, like to work with it, okay, yeah, I'm not gonna wait when it's loading. We're gonna change style. Again, yes, that's quite standard procedure. We double click, we go to symbology, and to change the layer, we're gonna actually use the layer which is already um, included. So the provider of this product also included a specific styling for this layer. So we find this little lonely button here all the way down, style, we click on it and we choose load style. We will load it from the file and we search this file in the same folder. Sorry, it's again a wrong folder. So it's Urban Atlas, and here we have a legend, and we choose one with QGIS layer settings extension. We choose it, we load, and now we see a lot of like a legend actually consists of different types of ground with different color coded and well also some number as a code too. So we click on apply and OK, and it will again take some time to load all these little polygons. Yeah, it will take some time, but I will not zoom, I think, in. Maybe I will. Okay. So by zooming in, we see that the colors are representing different well types of cover, and we see that so some buildings, for example, if it's urban area, they are grouped in like kind of same polygon. And well, okay, let me probably wait till it's really loading so we can see the overall picture and then we'll move on. But yeah, I will probably, yeah, I'll come back to you. So it's finally finished. I'm not gonna zoom because it's gonna mess it up again. So you see the all urban area, like a big, like metropolitan urban area of Florence, and we see in different colors. For example, here that continuous urban fabric is in dark red. We see some dark red and discontinuous dense urban fabric in red. We see some industrial parts in pink and different types of green for the well, green urban areas, forests, and yeah, some herbaceous vegetation associations, and so on. The yellow is some yeah cultivation, pasture, so some agricultural land. So what you're gonna do now, what we want to see here, is we want to like combine this data we have, this vector data of different types of a land, and the raster image, slide image we have with a temperature with land surface temperature, and by combining them two together, we want to see the mean land surface temperature per different type of land cover. So to see how different the temperature, land surface temperature of different types, like how hotter the urban area comparing to forest, for example. So to do so, we will use the zonal statistics function, which we again search for. Zonal statistics, it's here. And for input layer, we use, yes, this one, our land cover layer. For raster layer, we will use our concentration. No, not concentration, sorry, not output layer, but output. So our raster layer with temperature. The column prefix, well, okay. And then we need to choose statistics to calculate. We will need only one, but you can see, like, you choose several. I'm only gonna add mean. Okay, I will run it. And this, I believe, will also take time because, as we saw before, well, even to like display this layer on a QGIS takes sometimes because it's quite heavy. So to load it will take even more time. So once it's finished, I'll be back to you. So it is finished. It actually took less time than I thought. And you see that it has a zonal statistics, a new layer, which is all purple. And again, yes, we change its properties to well, represent it better. But actually, I'll show you the difference. If we right click on zone statistics and go to open attribute table, we'll see that we have all the table we had before. Well, if you open the one previous layer, you'll see it. But now we have a new column with mean value, and you see here we already have a mean temperature values. We close it, double click, and go to style. So, single symbol again goes to graduated. Value is gonna be mean, and color ramp, well, let's choose the turbo again. Oh yeah, little break. Invert, we don't need to invert. Tuck, tuck, tuck. Mode, pretty breaks. Classes, let's put 9. Is it 9? Yep. Okay. And we will apply and click OK. I actually will untick this one so not to have too many things. So now, if we zoom in, let's really try to zoom in like Florence, Florence. We'll see this very pretty picture. I find it's very pretty. And we see also that, well, dark red is from 50 to 53 degrees Celsius. There's also 45, there's 40, and well, going down with the color. And I see that in the very dense urban areas, like well here, we see that the temperature reaches 50 degrees. Like it's a lot. It's really a lot. And well, we see that also the more we are like far away with forests and our land, more and more we are more fresh, right? So that's it. And the next step, what we want to perform is to compute the temperature statistics for each land cover category to like quantify these differences which we see by looking at the images. So statistics by categories. For this, we will need to work with the same layer and yeah, I think we will need to create a new. No, actually, we will stay with this layer, yes. So we will double click on it. We go to fields. Where is it? Fields. And we click on Open Field Calculator. So here we can add more fields. And we will create a new field, create virtual field. And output field name, let's put temperature per area. So here we want to compute the weighted mean temperatures over each land cover category. So for example, I don't know, like dense urban areas, and so on. And also like taking into account the surface of each polygon. As you can see, we will choose output field as a decimal number and expression, we need our field and values. Yep. And we need our median temperature. Well, that's our mean one. Yeah, this one. Multiplied by area. Great. And now we have some preview also if you want to see. We click on OK. And we have a new field with expression here. So we click on OK. And now we go to processing toolbox to find statistics by categories. I don't see it. Okay, it's here. Statistics by categories. And input vector is our statistic. Yes. With a new field we just created. Field equals statistics on. So that's exactly the field we just created. This is temp X area. And next field with categories. We need what? Class or code? Class. I think, yeah, class. Class. Well, you can save it. Or maybe not save it. We're not gonna save it. I'm gonna just run it. Quite quick. And we have a new layer like this. This layer is not depicted as a vector or raster layer, it's just a table. We will repeat the same procedure by clicking, where is it? Statistics by categories. Total statistics, we'll take calculate statistics. No, now we will check an area. And fields with categories, class, okay. Let me just verify what it's okay. Repeat type version. Area. Okay, yeah, should be good. Close. We will put it up and actually let me rename it. Yeah, I will rename it to not misunderstood them. So I'm back and I just changed their names. Well, that's it. You just right click and you rename layer. And now we have these two tables. If I right click and open attribute table, for example, that's how it looks like. With more values now, you see. And before we going to compute our weighted average, we're gonna merge these two folders. No, it's not folders, databases, into one. So to do this, we are going to find another function which is called join attributes. Oh, join attributes, and we need one by field value. Yes, this one. Here, input layer is our temp area. Table field is class 17. Input layer 2 is area starts. Yes. Table field 2 class 20 tag. Okay. join type, take attributes of this originally. I think so. And we're gonna save it. And well, we're not gonna save it. Yeah, we're just gonna run it. Run, and it's finished. Now we have joined layer. And if we open attribute table, we see that it's well bigger because we have basically everything, every feature of one table merged with. So you have both tables in one table. And now we can, in this join tables one, we can join layer, we can add a new field. And as I already told you, you can just double click and go to fields and open calculator, field calculator, or we can do it here in attribute table 2, where it's the same little um, icon. It's also here on a ribbon. So we click on it and we create a new field, create a new virtual field. We also put it as a decimal, and the name is average temperature. Average temperature. And the expression is, I will just copy paste it. Oop. Which is basically is a sum of like temp, like this layer, temp area sum, and sum 2 is the area of, oh, sorry. So sum is the like variable called sum coming from temp area, and sum2 is a variable coming from area stat. So we have it, and we click on OK. And we have a new field, average temperature. Yes, we have a new one. So we close it. Well, you can actually check to see it's actually quite high average temperatures that we see on it. And next, if wait, I actually went to quick. Okay, we first organize columns by this little thingy, and in this we will change a bit its view. We'll deselect it all, and we only select class and the average temperature we just calculated. Okay, so that's how we see our little table now. It was quite big before, now it's prettier. And it shows us the average temperature in degrees Celsius acquired by, well, the end of June 2021 over several land cover categories in Florence. Yeah, well, and here, sorry. Well, if we'll increase this one to really see, if we click on it to make it, to like order it by maximum value, we see that it's in airports, the highest value, in continuous urban fabric, industrial, commercial, public, blah, blah, blah. And if we go very down, we see that forests, vegetation, very low density urban fabric, and stuff like this, pastures. We see that the highest temperatures are indeed in the dense urban areas and in industrial zones. Yeah, the Soviet airport also shows exceptionally high temperatures. And green urban areas tend to be a little cooler, but it's mostly, we can also notice it by looking at the map, but it's outside of the city like agricultural areas, forests, and like field, where temperatures are the lowest, right? Like here and here, well, mostly even here. So that's it. That was the exercise. And it's also the end of our tutorial. So today we looked at air pollution in Italian cities and also at the land surface temperature in, well, in Italy and more specifically in Florence. For this we used different layers. We worked with raster layers and vector layers. We learned how to combine information from both types of layers. We learned how to um, work with external data, external CSV files, external vector files, how to import them. We learned how to change styles. We did it a lot today for different types, again, for vector, for raster, to make it more like categorized and stuff like this. And yeah, we learned very important calculations such as zonal statistics, as cell statistics, to be able to see more precisely like different like differences between different areas, like in this example. And also, yeah, we learned how to add more fields, like new fields to vector layer and use some expressions in it. So that's it. That was it. I really hope you enjoyed this tutorial. I hoped you learned something new. And yeah, don't hesitate to replicate it fully or maybe I don't know, apply it to your own study, your own zone, own products, because, well, this tutorial, that's what's good about it. You can use it as a base and, yeah, like look at it, but like apply it to different topic, different region, different data from Wiki products, or even other products. So yeah, once again, I hope you enjoyed it. I hope you learned something new, and I wish you all a good day. Bye.